Statistical inferences involves drawing conclusions and making inferences about a population based on sample data. If you have your data set, you want to draw conclusion, that's the point we talk about the inferential statistics. And we hinted this on our second or third lesson on this video series. If you did not start from the beginning, you may need to go back and watch the whole of the series. You will learn a lot along the way. But we talk about hypothesis testing as one of the measures for you to infer. In hypothesis testing, it's used to make decisions or draw conclusions about a population based on sample data. It involves formulating a null hypothesis and an alternative hypothesis, and then you perform a statistical test to either reject or accept that hypothesis. I gave an example sometimes back, but let me give another example today. If you want to assess an association between maternal health and family income, for example, your null hypothesis would be null, no, nothing. Your null hypothesis would be there is no relationship, there is no association between a person's maternal health and their family income level. That would be null. So null hypothesis says that there is always no association, no relationship, no. So every time you are stating your hypothesis, make sure if you're dealing with the null, then you are talking about no association. If you're talking about, and the alternative is vice versa. The alternative hypothesis in this case would be there is an association between a mother's maternal health and the family's income. But generally in research design, research studies, we tend to only write one hypothesis because we need to reject one. So writing one, since the other one is the opposite of the other, we just write one. But in most cases, people prefer using the null hypothesis. So that's one way you can arrive at a conclusion if you have a data set. But you need to run statistical analysis using those softwares, and we shall learn some of them within the channel. So make sure you stick around. I have a lot of plan for this channel. Now you can also use confidence interval for you to draw conclusion. So confidence interval, it provides a range of values within which the true population parameter is likely to fall with a certain level of confidence. So we shall explore this with the time, that some values must fall within the confidence interval. When you do things like regression or even regression analysis, those logistic the logistic regressions and the Poisson regression and a number of those other statistical tests, your outcome, like your odds ratio or your incidence ratio, needs to fall within a given confidence interval. If it falls outside, it's even highly impossible. But if it falls outside, that's automatically what you you failed the analysis. It's a very important test in that case. Another measure for statistical inference is p-values and significance levels. P-values. A p-value is used in hypothesis testing to decide whether to reject the null hypothesis. So it is based on a significance, either 0.05, 0.01, 0.001, something like that. Now, this one we shall explore much into details about p-values. Most people do struggle understanding them, but that's a probability of the outcome of interest falling within the required range or the required probability, and most of them lies between it's 0.95 averagely, but it can be 0.95, you need to fall within there, or 0.90 in case it's 90% interval, or 0.999 in case it is a 99% confidence interval. So in case you fall outside like that, so let's say you're less than 0.05, less than 0.01, then that will become a very significant finding. Now, it's also important to talk about the type 1 and the type 2 errors. Now, these are errors that comes about when you either reject or accept hypothesis wrongly. And it's one of also the basis for statistical inferences. So type 1 error occurs when the null hypothesis is rejected even though it is true. And this is mostly they do arrive when you perform a wrong statistical test, use the wrong statistical method, and so you can get an error. Like, so, or a type 2 error, this one occurs when the null hypothesis is rejected even though it is false. Again, all this would come from which statistical analysis did you use and how did you arrive at your final conclusion. Now, the most important aspect of arriving at a conclusion about your data set is statistical tests. You need to perform statistical tests for you to get those p-values, for you to then either accept or reject your null hypothesis. And some of the statistical tests can include the t-tests, the chi-square test, ANOVA test, regression, or some non-parametric tests like the Wilcoxon or Mann-Whitney test. There's so many other statistical tests. So we will explore in this future video some of these statistical tests. So in case you want to learn more about these statistical tests, make sure you check and subscribe.